Hi again, Pre-Algebra. This is now number 1 on the second page of the packet I gave you. It's the second e-learning assignment. This one is on trend lines or line of fit, which is what we did in class a little bit on Monday. I've also attached my notes in Echo, so if you did not take all the notes or you did not take them home, I'm doing you a favor, you can look at my notes. Alright, number 1 says the scatter plot shows the weights Y of an infant from birth through X months. So on the x-axis, I'm looking at the age of an infant in months. On the y-axis, I'm looking at their weight in pounds. Part A, at what age did the infant weigh 11 pounds? I'm going to my weight in pounds. I'm looking for 11, halfway between 10 and 12. This point right here, if I go down to the x-axis for age, it's halfway between 2 and 4, which would be 3. So part A should have 3 months. Part B is asking what was the infant's weight at birth. Remember, the second you are born, you are 0 months old. That is your initial value or your y-intercept. In this case, when the infant was 0 months old, it looks like they were halfway between 6 and 8. We're going to call that 7 pounds. So this infant weighed 7 pounds at birth. 7 pounds. Part C, draw a line that you think best approximates the points. So this is where they're asking you to draw the trend line or the line of best fit. Hopefully you have this on paper so you can do it nicely. I'm going to try to drag this line over here over. Remember that you want your line, first of all, to be straight, and you want the same number of points above and below it if you can. So I'm going to do, this graph is actually pretty nice. This is my line. Right now I have like 1.5 below and none above, so I might move it down just a little bit. Well, now I have more above. Maybe my line's just too fat. I think this is the best I'm going to get. So, part C is done. Nothing to write down. Part D, I need to write the equation of my line. So remember, I'm filling in y equals mx plus b, where, equals mx plus b, where m is the slope and b is the y-intercept. So I need to fill in some blanks here. Something x plus something. Y-intercept is probably easiest. My line conveniently went through the point at 0, 7. So I'm going to just say my y-intercept then is 7. Your y-intercept might be a little bit different. Maybe it was 6, maybe it was 8, maybe it was some decimal in between. Now to find my slope, I need 2 perfect points. I have, that point's not perfect. It's not quite on an intersection. I think I'm going to call this point right here perfect and this point up here perfect. There, that's as close as I can get with the line I drew. So from here I rose 1, 2, 3, 4 boxes. But remember the boxes are counted by 2, so I actually rose 8. I went from 12 to 20. So my rise is 8. My run, I ran 1, 2, 3 boxes. But again, I'm counting by 2s. I went from 4. Wait, where did I go? I went from 4 to 6 to 8 to 10. Okay, yeah. So I ran 6 months. 8 over 6 as a fraction, I could simplify. I could divide both of those by 2. So that would be 4 over 3. So my full equation is y equals 4/3 x plus 7. Part E, use the equation to predict the weight of the infant at 18 months. So first I'm going to ask myself, am I looking for an x value or a y value? They're asking me to predict the weight. Weight over here is on the y-axis. So I'm looking for a y value. Let me type this down. I think that's going to be helpful. looking for y. I am given 18 months. Months is the x, so I'm given x equals 18. And now I can use my equation, except instead of an x, I'm going to put in an 18. So instead of y, I'm still going to have y equals because I'm looking for y. I'm still going to have 4/3. But then instead of an x, I can put in an 18 because I'm not looking for just any x. I'm looking for the specific x of 18. So 4/3 times 18, still plus 7. Now I've got some fraction multiplication over here. Let me start a new text box for that. This is not the ideal place to draw or write fractions, as you can probably imagine. So 4/3 times 18/1. I need to multiply straight across. So first I'm doing 4 times 18. I don't know what that is. I'm just going to put it in my calculator. That is 72. And then across the bottom, I'm multiplying 3 times 1 is just 3. 72/3 seems like it should simplify. Remember that a fraction means divide. So let's check 72 divided by 3. Yep, 24. So that did simplify nicely. So now, if I go back to this equation over here, 4/3 times 18 was 24. I still have the plus 7. I have not added 7 yet. 24 plus 7 is 31. 31 sounds right. And I was predicting the weight, so it would be 31 pounds. To be safe, I'm going to see, okay, does that make sense with my graph? 12, 14, 16, 18, that's out here somewhere. It's kind of nice, I can just drag my line even farther. If I say around here's 18, does this seem like it would be around 31? Well, let's see. 24, 26, 28, 30. Yep, makes sense with my graph. Does it make sense with my situation? Yeah, I would say a kid that's 18 months, that's like a year and a half, it makes sense that they could weigh 31 pounds. And then last but not least, question F, does the data show a positive, negative, or no relationship? When they're asked about a relationship, that's the same thing as when we talk about association. This graph from left to right is increasing or going uphill. So this last question is actually pretty easy. It is a positive relationship. I think the hardest part of this is using or making your predictions. So if you have any questions on those, please feel free to ask me. My email is in the agenda. Otherwise, I hope you're staying warm and have a great day.